Welcome everyone to the May 2025 ZFS leadership meeting. Thanks everyone for coming, and I guess we'll start at the top with the big news, the introduction of the Anyraid feature. Paul, do you want to take away and kind of give people the background on what that's going to look like?
Yeah. So ZFS lets you do a lot of cool stuff with storage and with vdev configurations and sort of how you lay out and protect your data. But one of the big restrictions on mirrors and raidz devices is that all the disks need to be pretty much the same size. If they're not all the same size, you only get the capacity of the smallest device in the vdev. And so that restricts the utility of having sort of arrays of mixed devices. For a lot of production use cases, this doesn't matter because, if you're setting up a giant storage array somewhere, you can afford to go buy a box full of hard drives that are all the same. But for users with lower budgets or some old drives that they'd like to keep using, the ability to use devices of different sizes would be pretty handy. And so the idea of the Anyraid vdev is that you can set it up to use mirror parity in the initial version, or eventually raidz parity. And it can mix and match devices of different sizes, and it allocates, basically, it picks some subset of the devices to allocate a particular stripe of data on, puts it on all of those devices, and then selects a new stripe for the next block of data. So you don't use the full width of all the devices. You use some smaller size so that way it can pick and choose and allocate more data onto bigger devices and less data onto smaller devices. And it allocates these sort of stripes in large chunks so that we don't have to keep this giant in-memory map like we do for something like dedupe or device removal. It allocates these regions, I think the default is something like 64 gigabytes at a time. So that way, you allocate this region, you write to it for a while, and then once the region is filled up, it goes and allocates new regions on a new spread of devices so that way you're always working towards filling all of your devices as much as possible. And so this lets you take advantage of devices with a very big mixture of sizes, and still be able to use all of the storage that they present to you and also get the redundancy and reliability that ZFS provides.
So yeah, with the prototype, which we'll post shortly, that supports mirroring. So if you mix 4, 5, or 6 drives together, it will make sure that every block is written to 2 of those drives, or 3, depending on your configuration. But it will vary which sets of drives as you write more and more data, so that, as Paul said, if you have, an 8 terabyte drive mixed with a bunch of 3s or something, it will have one copy on the 8 and one on the first 3, and then a different block will be the 8 and the different 3, and so on, so that you get kind of the maximal usable space. Another part of the design is when it's creating those 64 gig like substripes, or we don't have a good term for them at the moment, but it tries to defer doing that as late as possible, so that as the topology changes, if you add more disks or increase the size of one of the disks by replacing it, that it can take the maximum advantage of that and hasn't already filled up your biggest drive with all of its size, so that it can get the most usable space possible. And then possibly in the future, because of the way we have the mapping table of these kind of 64 gig regions to where they are on disk, we could move an entire one member of that 64 gig region to a different physical drive without changing DVA within the vdev, which would allow kind of rebalancing, but without needing block pointer rewrite or something like that. The data would stay kind of using a similar mechanism to what raidz expansion does, except for just with a remapping table, but similar to device evacuation, but on a scale of like 64 gigs at a time rather than each individual block, so it won't have kind of the memory cost that device evacuation does.
Do you understand right that it will have one single vdev that even in case of mirror will have like half dozen or dozen drives of different capacities?
Yeah, that's right. So it's a single top level vdev with a bunch of children. and it like internally dispatches the writes out to the different regions and reuses the existing mirroring logic to handle that part of it.
And inherits all the
So
healing and all the other stuff.
So it's somewhat similar how derate is wrapped around raidz. So
Yes,
you will
very
still
similar.
call mirror code, but otherwise stay outside.
Yeah, and the plan for the future raidz enhancement is that it's also going to call into the raidz code and wrap around it in a very similar way.
I was just worried how much mess will be in mirror code or later in raidz code.
There was almost no change to the mirror code. Like basically the only change was moving the definition of the mirror structs into a header so that we could allocate them in the new code path. But none of the actual logic for the mirroring code changed.
Okay, we'll see. I'm also a bit suspicious about this functionality from its complexity side. But if you say it's not that bad. But
we'll get you a branch to start looking at.
But I suppose, do I understand right that first write attempt into those 64 mega whatever gig chunks that will trigger its allocation?
Yeah, that's right. When it goes to do an allocation into a region that isn't mapped yet, it grabs the right lock and picks which disks it wants to allocate those regions on, and then it lays out the space, and then it can start doing allocations from there normally.
I wonder how it maps into MetaSlabs logic when on a big system we may have 4 allocators, each may open 4 MetaSlabs. We have 12 MetaSlabs open, potentially spread through the vdev surface. So how much space do you actually map immediately?
Yeah, so you do map multiple regions immediately because, as you pointed out, you end up with these, can have several allocators at once that are all writing to different areas.
But I think that's also important in order to, especially if it's a mirror and you have 5 or 6 disks, you want to make rewriting to more than 2 of the disks at a time most of the time, right?
Yeah, and so even if you do end up, immediately allocating like 5 or 6 different regions, because the way that the region size is selected, it starts off the region size is I believe it's a 64th of the smallest drive in the pool, or I think it's actually 16 gigabytes, whichever is smaller. And so the idea is basically if you have really big disks where you would have, on a system where you might have like many, many allocators going at once, your regions are also going to be correspondingly larger. And so more metaslabs will naturally fit into those regions.
Another question about regions, how they are mapped into the virtual address space of the vdev. So if you are writing sequentially, will you write just into mirror, will you just write to 2 disks, or it's similar to derate will rotate, or it rotates at what granularity? Because derate has fixed 16 megabyte, and even that is pretty big. But would it be just normal mirror? It would be handled by the MetaSlab allocation code, which especially after my rewrite, it does it like a couple megabytes per disk, balances based on capacity and performance and so on. But primarily just smaller. It may be like 2 megabyte or maybe less for bigger blocks, but still round robin is pretty active to have single threaded workloads.
So it will put it, so if you do like a large contiguous write, it will go into the MetaSlab code and it'll mostly allocate, from the few different allocators you have active.
Oh yeah, but a single file is written only by one allocator. So if you're
mostly there are some block boundaries, but yeah, mostly. I think we use the offset divided by some number.
Yeah, maybe, but that is pretty big. So generally, it's one allocator.
Yeah, so you'll end up with most of the all the allocations in one metaslab, which will get written to one region, which, if you have a one wide mirror parity, it'll pick 2 of the disks and it'll just be writing to those 2 disks for that block of data. This is the downside.
Like significant downside.
From a performance perspective, it's a downside. The goal here, performance is not the primary goal of this design. The goal is really providing the resiliency, like the full resiliency of your selected parity level and the ability to use all the provided space. Performance is a nice to have. And like we're doing what we can to try to improve it, but not at the cost of reducing the space capacity.
I wonder
in particular,
if
once it's raidz, you'll be activating almost all of the disks in the vdev for every write anyway.
Yeah,
and so
mirrors are worse
the
for
downside
this.
won't be as strong as with mirrors.
no, it just also most of significant part of the benefits of this scheme with different capacity appears as the more drives you add of different ones. Even if you set up raidz, if only one or two disks are bigger than others, you won't be able to use this feature. You really need to have more than your raidz width of different capacities to actually get anything good out of it.
You can still get pretty good benefits as long as, so even if you have like only one or two more disks than your width, you can still.
No, I mean only one or two disks of bigger capacity.
Yeah, but
Otherwise,
even if you have only one or two disks of larger capacity, as long as you have your width is a couple devices smaller than the full size of the device, you can get a pretty effective space usage. The math is not super simple. Technically, I think it's an NP-hard problem to determine how much space you get out of any given layout, because it's a variant of the bin packing problem. But we tried out a bunch of examples. We made like a little calculator, and in practice you get a lot more space out than you might expect in a lot of configurations.
But in case of raidz, will it be same as draid when you have different vdev width versus stripe size, or they will expect them to match? Because if they match, then different sizes logic may be difficult. If they
No, it's going to be, so the raidz stripe width will be lower than the number of children of the Anyraid device.
Oh, yes, similar to draid. Yeah, that way for raidz it may indeed be some better, but I wonder if in case of mirror could be implemented a logic similar to draid, like in 16 megabyte chunks, you rotate them around. Even so, you may be allocating 64 at a time if you wish, but then rotate more often. Because sequential,
it'll depend on the use case. Like you said, if you are writing with more than one thread to more than one file, then you're going to have different allocators writing from different meta slabs, and you're going to activate all the disks anyway, and so you get the full bandwidth. It'll just be if all your writes are to one file that you're not going to get all the disks.
Yeah, you're copying multi-gigabyte video file, and you're practically writing it to only 2 disks at a time.
Yeah.
Wow. So that feels like limitation.
Yeah, there is a trade-off, which is that so the way that the most complicated part of Anyraid is really the mapping, that like storing the mapping that maps from regions to like the actual locations on disk. And the problem there is that we can't store that mapping in the MOS or anything, because in order to read the MOS, you have to have enough of the mapping to get to the to read the relevant blocks. And so the mapping is stored sort of after the labels, but before we actually start storing data, we just like allocate a region there and store the data in there. And the size of that region right now is so if you have 64 megabytes, you can store the entire mapping at the maximum number of like regions per disk and disks per Anyraid vdev. But if you like try to shrink the regions down so that you would get it to spread across more devices, then you would need to increase the number of regions per disk, which means that we would need to make that mapping area larger, which we could do. It wouldn't be the end of the world, but the space goes up.
Well, I don't mean creating a separate region for every 16 megabytes, no. But similar to how it's done for draid, when you practically set up a single vdev, and within vdev you have fixed distribution patterns that never change. In your case, it will be more flexible since you need to handle different disk sizes and so on. So there will be a number of mappings, maybe up to the same 64 megs, but within one mapping, you may have more Correct. You need to specify for those 64 gigs, use those disks, use those offsets, use those topology, go and calculate all the distribution.
Yeah, that might make sense. Paul, what about the passivating thing we did for the other project? Would we be able to maybe just convince ZFS to switch metaslabs more frequently in order to like
Yes,
just
you can.
start allocating the, that single stream for like, but I guess then you're just switching to two other disks and two other disks. You're not actually doing all of them at the same time. So that wouldn't help.
Right. And the other sort of the fundamental problem is that like if you have, uh some like a mix of larger devices and smaller devices, writes fill up devices. And so at some point, like you want to fill up the larger devices more than you fill up the smaller devices. So you have to issue more writes to the larger devices, even if they are, like already at their bandwidth limit, because you like want to be spreading the writes out basically in proportion to the size of the devices. So there's always going to be some cases where you can't use the full capacity of the array because you're trying to more heavily balance the writes towards the bigger disks so that you can use all the space.
Yeah, but maps feedback is interesting to look at, especially the single writer case, to see if there's anything we do to just swizzle that more and see if we can't. Although even with a single writer, no matter how you swizzle it, you're still going to end up with you're writing to these two disks, and now you're writing to these two disks, and then back and forth, the kind of thing. You're not actually going to light up all four of them continuously.
Unless the regions were split across more disks in sort of like a more DRAID like way, but then you start to have a lot more interesting logic on top of the mirroring logic. And I'm not sure how we would store that in the current representation of the region mapping. That might get more interesting to implement, but it's definitely worth thinking about.
Any other feedback from anyone? Yeah, and like I said, we'll get a pull request for that put together relatively soon so that people can start looking at it. But it kind of leads into the next topic of, we need a place to put this mapping table. And, if that's a 64 megabyte region, we don't have one right now. And that leads to our conversation from the Dev Summit about redesigning the ZFS label to be more extensible, reserve more space, and kind of have, to Mav's idea, a kind of table of contents where we can dynamically allocate that space to different things depending on the type of pool that's being configured and so on. And so, Paul, you had put together a proposal for that as well?
Yeah, there's a discussion on GitHub in the OpenZFS repo under the discussions tab. I laid out a little bit of the stuff that was discussed at the Dev Summit, sort of the high level stuff, and then asked some questions. I got some feedback from people, which I appreciated, but I would be happy to have some more feedback because it's starting to get around time to actually start implementing things. And the more questions that we can get good answers to, or the more ideas we can get generated, then the better that implementation can be the first time around. And hopefully we can have a more efficient and productive PR rather than having really good ideas come in really late in the process and require rewriting and redevelopment.
I haven't had time to look on the discussion. I was just wondering whether you had that stream from the last OpenZFS summit to make sure that everything discussed there is considered.
Yeah. I went through and I rewatched the video and I rewatched some of the Q&A part of it, and I talked to Alan a little bit about the discussions that we had afterwards. So I tried to incorporate all that stuff in there. If I missed something, I'd be happy for people to take a look and let me know.
Yeah, because I think there's some considerations Mav had brought up about, is there anything we can do as part of that to make imports faster? So like one of the things we talked about is having the whole pool config be available on any individual disk instead of only the one vdev that it's a member of, since we'd have room for that. And a bunch of things like that are just like, how can we make the pool faster to import based on experience, especially that Rob and I have had, things we can do to make pools more recoverable. So longer rewind back further more transaction groups and things like that, and anything like that. And then obviously one of the main points of the label redesign originally was dealing with these SSDs that are coming with 64K sectors and so on, and making sure that we're accounting for all that, and just any other ideas that we have on what we need to do to kind of future-proof those parts of the ZFS on disk format, so that we don't have to make a painful change again in the future. This is already looking at how we're going to try to make this so that an older version of ZFS will be able to tell that it shouldn't try to import the pool and so on. How do we end up with something that isn't, oh, we have to take all the original label space and reserve it if it's a label that's purposely broken or something that cause ZFS not to import it, and then have it look elsewhere for the real label and so on. So especially anybody that has ideas about how we handle the upgrade path, or like just the compatibility between versions of ZFS and all the other things, but especially anybody who has to deal with ZFS in bootloaders and so on, if there's anything that would make their life a lot easier, we'd want to try to incorporate all that stuff in at once. Because I know we also want to get the feedback from, I think it was the Dev Summit 2 years ago, where Brooks Davis came and presented about the problem with the way we were using the MV list in the labels and how that was breaking the Cherry hardware, because we were storing like a pointer or something that turns out if your CPU is not 64-bit, it's different, and so on. But yeah, definitely interested in anybody's feedback on that, or anything related to what we should consider when redesigning the new version of the label. Okay. Next up was one from Tony, Synchronous zedlets. You want to talk about the use case for that a little bit?
Yeah, so this is basically a way that you can make sure your zedlet runs synchronously so that no other zedlets are running when your particular zedlet's running. And this is useful for, like, if you have a drive that gets faulted and then it goes back online again, you're going to generate a state change for the fault and then a state change for the online, and those will launch a zedlet. But the problem is those get launched asynchronously, or they currently get launched asynchronously, so the fault event doesn't exactly, or the online event doesn't wait for the fault event zedlet to finish. And so this could be problems if your zedlet is turning on or off fault LEDs. You could get them turned on or off out of order. So basically this PR adds a way that you can make sure your zedlet's the only one running at any given time.
Does it have any protection against, the zedlet gets stuck and never returns or something?
Timeouts, maybe.
Oh, go ahead.
I mean, it would be good to have some timeouts or otherwise server recovery.
Yeah, just like if
somehow the code path itself isn't different for launching the zedlets.
Okay. Go ahead.
Yeah, that's all I have for that.
Okay. But yeah, I think short of something like, if it's been 5 minutes, then give up on it or something, could be useful just to make sure that, if somehow it gets stuck trying to turn the LED on, that it doesn't stop every other event from happening. But yeah, I can definitely see the useful case, like you said, when things kind of flap very quickly, that you kind of don't want all the operations to fire off asynchronously and possibly complete out of order.
Yeah, just 5 minutes is quite a lot. If you have dozen of disks, and then somehow you attempt to set one LED takes a full timeout of 5 minutes, it will take hours.
Mm-hmm.
So it would be good if it was possible to set some expectations.
Mm-hmm.
And after that, either kill the script, or if not killing, just allow the next to proceed despite that one stuck.
Yeah, I think that makes sense. Do you guys have a timeout value that you think would be reasonable?
I would say it should be per script. I don't know if there any place to put it. Is there any metadata inside or any description other than a name? So considering you've used name for a sync prefix, I guess not, but maybe it could be like sync 5, feed 5 for, I don't know, seconds, or like if script has 5 seconds guaranteed synchronous execution. If it won't complete in that time, it's its own problem.
Yeah, that might work. Okay, we'll have to think about it, but yeah, you're right about the timeouts.
Yeah, because I can see, like, you know, turning on an LED shouldn't take more than 5 or 10 seconds, but some other operation might take longer, and so being able to control it per script would be nice, but I don't know if we'd have to build a lot more infrastructure to be able to support that. Although it may be worth doing that as well. Okay, the next one on the agenda is somebody from Nutanix has posted the PR for hierarchical project quotas. So ZFS has had project quotas for a while from Sun, but this allows them to be hierarchical so that if you have a limit from a parent, that it can ensure that the sum of the children doesn't go over the limit of the parent. And it's pretty well described in the pull request, but I'm guessing that will need some review.
I haven't looked on Apache. I'm just curious, is there any OS actually have that hierarchical quotas, or no, hierarchical project, a general concept, or it will be specific to ZFS?
I think it is mostly specific to ZFS. I don't know that anything else has the concept of a project rather than just a regular file system quota.
Is it? I had feeling Linux has some mapping for projects. I may be wrong. FreeBSD doesn't, that I know.
No.
But I had feeling Linux has some, but I don't know for sure. I think we export project quotas somewhere to VFS on Linux. But again, I haven't looked close.
Yep. And then next item is Alan Summers has a discussion going about the proper way to protect the DMU buff data. Looks like that's starting to make some progress in figuring out what's what and coming up with a pretty big grid of what is protected by what lock and so on. But it sounds like he's still trying to figure out exactly what the right answer is for a couple of those.
He produced one patch that we already merged upstream that just removes some questions, streamlining some accesses, like not exposing buffer until it's full and so on. That's kind of makes sense. But I haven't seen very much progress after. Pavel Snyder does some attempt there to do some more, but it seems like he's jumping a bit here and there rather than I would just go slower and fix each ugliness one by one until some hopefully good result is achieved.
Yep. Yeah, just wanted to make sure that that gets some attention from other people if anybody has any input there. And then another one from Nutanix is a Linux specific fix for inode eviction with a synchronous writeback that currently can cause a deadlock. At Klara, we're looking at a semi-related thing with managing the eviction of inodes from ZFS a bit more intelligently. But I think, Rob, there was something else I wondered if this was related to that you were looking at yesterday with, I think it was msync.
Yeah, I don't think, I don't think it is unless it's at some distance.
Okay.
But I'll have a look properly.
But yeah, I don't know if anybody else has encountered this deadlock that Nutanix has, but it'd probably be good to take a look at that. It looks like it's specific. I don't know if they mention if it's the problem is specific to newer Linux kernels or if it applies more widely. It mentions some really old PRs on the GitHub here, so I'm guessing it's not specific to the 6.x kernels.
I haven't looked in the inode site. I just recently looking through some memory allocation code. I've noticed that it seems we do not evict denodes for deleted files, and they stay until we evict the whole block. I was thinking that would be great if we could evict those somehow more actively, but I'm not exactly familiar. I haven't looked close right now with looking about that. Maybe there are some complications. But on number of tests with a lot of files, like spec SFS benchmarks that creates zillion of files, ZFS practically get limited, not by performance, but literally by the number of files, because the test tends to simulate workload based on scaling number of clients, which means scaling number of files. And we get out of memory before we get out of performance. So it would be really cool if we could evict denodes properly if somebody is looking for a project to work on. That just recently scratched my eye.
Yeah, because we're even looking at just evicting things when that's just inactive, not even deleted, but just like, especially in the newer 6.x kernels, they changed how much the VFS layer in Linux tries to evict inodes and D entries. And it's seeming much less aggressive now, and can result in the Linux side of the VFS pinning down a whole bunch of D nodes that you would like to actually be able to evict.
That's at least on kernel. Kernel supposed to have responsibility for that, but it may happen right now if kernel holds reference for one dnode out of a block. ZFS has all the dnodes for a block.
Yep.
On the other side, what's interesting, if you create a big dnode, then denodes it covers are actually evicted. Or if you have denodes that never existed, or if you imported pool, those are also not allocated. So like we are already doing something in between, but if we could potentially extend it further and to evict, especially those that are deleted, because at least ones that are not deleted, we at least have some hope that they will return and we are caching for something good.
Yes.
But if something is deleted, the FS is so lazy on denode reuse, I would bet that it very rarely happen. So we would evict, benefit really a lot on memory consumption if we could evict those.
Yeah, because I think the only time we were seeing more dnode reuse in the past was when there was that bug that got introduced with the signedness problem, where we'd loop back around in the inode numbers when we hit 4 billion.
I think we calculate some sort of spareness of the list, and then when it reaches some number of spare, we actually try to
restart using it. Yeah, but depending on your use case, that often doesn't happen very much.
Yeah, I think so.
Then the last one is we rebased the kernel kstat for getting the JSON version of zpool status. I know, Tony, you've got some kind of lockless version of the command line interface.
Yeah, I posted an updated version after getting feedback on the flags. So now you can set an environment variable called zpool lock behavior to either wait, which is the default, or try lock, or lockless. And if you set to lockless and your root, then you can do a zpool status without the lock. Or more specifically, it'll try to get the lock for like 100 milliseconds, and then if it's not successful, then it'll do the lockless version.
How does it get the spa T without the lock?
It just goes into the
AVL?
spa AVL tree and looks it up
Okay.
directly. And the nice thing about doing it that way, if it's like, okay, I'm already going to do it dangerously, I'd rather do it through zpool status then, since that's a familiar interface and has all the nice formatting options. You know, you could pass like -c to it, you could pass -h or -p or JSON. So that's where I was going with it.
Yeah. The main advantage to the kstat version is you don't have to go into the spa, the AVL tree at all. And so you don't have the risk of that imploding. The locklessness it has is for the vdev lock, for getting, or the config lock. And it can just return a bit less information if it can't get that. But I see your point about the advantage of the existing interface. And, you know, the danger was never really the motivating factor. It was just the, you know, being able to call it and reliably get information instead of getting hundreds of hung zpool status commands running. I don't know. I still think there's some value to the kstat, but go ahead, Alexander.
Oh, yeah, I just want to mention from other side that Rob Norris patch from the last night about exiting from the open transaction context. Oh, yeah, the assigning transaction context could potentially solve a bunch of things if we could kill processes actually that are holding the logs and so on. Really nice.
Yeah,
I commented to ZPRs, but I'm really happy to see that approach rather than anything else.
Yeah, we're building towards a new version of the forced export that Will Andrews had done in the past, to actually be able to, you know, take a pool that's stuck because, you know, the disk has gone away entirely and not coming back or whatever, and be able to kind of cancel the in-flight ZIOs and unwind everything and drop the locks, and get it exported so that, you know, if you have 2 or 3 pools on a system, the other ones are not similarly stuck because, you know, that hung thread is sitting on the spa namespace lock. And so, yeah, just more ways for ZFS to actually error out throughout things. There's just a lot of void functions in there that are quite annoying because of that. Or just the fact that, you know, before some of our patches, there was no way for fsync to ever return an error. It could only ever succeed or wait forever. And having a way to actually, as Mav said, cancel that is quite helpful.
Yep. We've got a lot coming that this area in the next couple of months probably. So between that and between forced export and yeah, fsync and things, we can throw everyone out. So that'll be good too.
I guess, Alexander, do you have, so we merged the parallel arc eviction stuff, and we have to get back to the same thing for the debuff eviction.
Yeah, I was going to talk about it slightly. I'm really happy to see parallel arc eviction. We already merged it into Turnas nightly, and I'm trying to push our perf team to actually run some things on it. Really happy about that. But about parallel arc eviction, I was also going to bring up because patch in its current version seems not really usable or useful or anything. It needs some more thinking. Since debuff eviction originally from the beginning was somewhat parallel because every thread that tries to allocate memory and sees heavy overflow will try to evict something. The only thing that's downside there is eviction is doing one block at a time, So overhead of locking, selecting multi-lists, waiting on a lock, and so on is pretty significant. I think would we
so
just
the original version was it would take the lock and find it, and then it would iterate through until it found something can evict, but then it would exit, return to the parent loop that would then call it again, and it would walk over the same items that it and try lock each item. Most of them it couldn't get the lock on, and it would basically iterate over the same items over and over again instead of doing a whole bunch under the one, the multi-list that it locked. And so that was a big part of what that improvement was doing at first, but I think it got a little crazy with the trying to parallelize it too much. So I think we can get something that looks a bit more like the original and more like the final version of parallel arc eviction.
Yeah, I don't think we even need here multiple threads, or like at least if we keep logic when every caller may be responsible for additional evictions.
The problem there is that those callers only do that when the eviction is blocking allocating a new one.
Yeah,
whereas
what's the
like
problem?
if we get behind there, it just blocks everything up because we can't actually free the bits of the arc until the debuff is freed first, right? And so the stuff we would do in the background in the single thread, I think it doesn't make sense to still have one thread that's spinning on the CPU a bunch of the time, evicting stuff, and having to make every writer do some extra evictions to be able to continue. I think it still makes sense to have some parallelism there. But yeah, I definitely wouldn't want to get rid of the logic it has now to make other threads do the work too if we can't keep up.
Yeah, from the point of restarting again and again, we could potentially reuse same logic as in Arc. We're using markers. Just put marker wherever if you want to return, and just
Or I
do
think
it
even just
faster.
Our original version was just evict at least 100 things before exiting, or something.
Yeah, 100 is a lot, but even 10 would be better, 10 times better than 1.
Yes, exactly.
I don't remember how many Arc uses for that, but I think it's more like 10 rather than 100.
Okay, 10. Yeah. But yeah, just especially because so many of the items it can't get the lock on, having it iterate over the same items it just did over and over and over again was not helpful. But yeah, we can take another look at that and get it closer to its original shape, I think, than the version that's there now.
I was wondering if we want to continue with it or can close as that.
Yeah. Give us a little bit more time and then we'll see.
Great. Well, sure, I would happy to see it solved.
Yep. Yeah, that one came from a customer that had a very large memory system, like 6 terabytes of memory. Wow. And so, and it was all full of ARC entries of 4K records. And so you can imagine why the parallelism was important to be able to make any progress. You had 100 cores all sitting there trying to read something, and there was no room in the ARC.
No, yeah, for ARC it absolutely makes sense. For debuff usually smaller, and there it may be more limited by performance rather than size.
Yep. Okay, were there any other topics that people want to discuss?
I just would like to notice, in case somebody missed, with Tony and Brian, we got to agreement to start 2.4 release cycle mid-August.
Okay.
So I just would like to remind about it. So if anybody has, everybody who has an ongoing project, would be nice if it would be targeted to that date, so we would not sleep it too much and actually made things more coordinated than it was last time. Mid-August is about time of next FreeBSD stable branching. So would we complete it by that time? I guess FreeBSD would be much happier, not needing to stay on master and stable branch or doing something other weird things.
Yep.
And then plan to do final release in late October or about October, I think. So then it would also work through NAS, and just for everybody would be good to have some predictable schedule.
Exactly.
Yeah.
Yep.
Do we need to like write down some target dates and maybe put the call out and say, hey, if you've got projects you're trying to, can we put together a list of projects that people have in flight that they want to try and get into this, just to sort of surface that, or is it useful? And partly so we can also say, well, you know, you missed the call or you didn't write down anything on your list. Sorry, we're not. I don't know.
Mm-hmm.
I mean, you've said it, so maybe that's all it needs.
I was thinking just to make sure that release schedule is clearly visible. Right now, it's published as one of discussions. I don't know if GitHub any better place for it for future releases for some.
Oh, I'll have a look. I hadn't actually seen it, so.
Yeah,
Sorry, I
make
just
sure a
posted
link to
in the
that goes
chat.
in. Thank you. I will make sure that goes in the notes as well. Yep, I think that makes sense. And so yeah, we will try to get the first Anyraid PR going so that it has time to, be mature enough for that.
Mm-hmm.
Great. Okay. Anything else?
Do we know when the call for proposals for the Dev Summit talks is going to be? I was just curious.
Matt generally handles that aspect, but is there a time frame that would be comfortable so you have adequate notification on making travel plans, etc.?
I mean, ideally we would have a date for the Dev Summit a couple months in advance, but I was just curious if there was a deadline yet for talk.
Dev Summit itself,
Yeah.
October 25th and through 28th. We haven't done a formal announcement, partly for want of confirming a large sponsor and artwork, but there's no super strong barrier. So maybe we'll get that out shortly.
Okay.
And I do welcome any and all feedback on format and food and you name it. And the new screen is up. There's upgraded AV. There's a lot happening behind the scenes.
Yeah, the user conference part was extremely valuable last year. So I don't know if we have any ideas on how to get even more out of that, but I found that very, it's always interesting to watch people holding the thing you built and realizing they're holding it wrong.
And can you
or the other interesting ways, yes, and other interesting ways they found to use it that you didn't think of, and be like, oh, exactly. Well, that gives me even more ideas, and so on.
Precisely. So yeah, that feedback is encouraging, and that's what I wanted to achieve, is just sort of let's pound our heads together and show what we've done. I'm easy to find, reach out outside of this.
Right. All right, thanks everyone. And we'll, next meeting will be at the early time on June 17th. Thank you, everyone.
Take care.
Thank you.
Thanks.
Bye.